Well, hello everyone. My name is Victor Hernandez. I'm really happy and excited to be here. I'm going to talk about some things that I'm very interested about, and it's just psychedelic explorations and then its connection to AI, machine learning to be specific, and neuroscience research. Just to start, just to introduce myself, um, I just graduated from a master's program actually yesterday, um, and I am very interested in neuroscience research and its application with technology, and at the same time, psychedelics really are a great tool that we can utilize to learn more about the brain, as well as to create new therapies to help people. So let's dive into this. So, just to introduce the brain and what it means, we know that the human brain is small. It regulates many things that happen in our day-to-day lives. Many physiological responses as well as behavioral responses, but it's also in charge of our thoughts, our emotions, speech production, what we think, all that processing that happens up here. All of these factors give rise to consciousness. It gives rise to who we are, what we are. So it really makes us think, is everything up here? It's everything that we are up here in our brain. So the connection with this of psychedelics and the neuroscience research is that psychedelics um, and things such as psilocybin have been used as a tool to gain this insight in the very complex network of the brain. As I mentioned, the brain is in charge of many physiological responses as well as behavioral, but also it gives rise to who we are, and what we think of ourselves, and also as a collective community. So psychedelic drugs can really help us into exploring individually neural mechanisms in brains, of course, but also using psychedelics and drugs such as psilocybin, it can help us in creating therapies to treat mental health, which is very important and is something that's very close to me. And something that I find very important is to understand consciousness, understand what makes us. Once again, what makes us individually, but what makes us as a society, what makes us all together. And psychedelics can really help us unify that idea, but it can help us unify and understand what consciousness really means for us. So this comes to mind, and this is very personal to me. What about the people that are not really interested in psychedelics? What about the people that look like me, like my parents, a lot of my communities? Myself, I am a Hispanic. And I've always been told, oh, don't believe in science. Oh, don't believe in research. Don't believe in medicine. Don't do any of that stuff. And of course, there are some historical representations that really makes us think, huh, I really shouldn't believe in that. But just to be ironic, now I'm talking about psychedelics and I'm also on my way to become a scientist. But the reason why I know that it's because throughout my career and throughout my experiences, I've learned that we need to make information more accessible. But not only information and science and therapy is more accessible to people, but the whole reason about we're doing all of this is because we really want to help. We really want to treat the communities that are in need and that struggle with many things. Psychedelics can give us all these benefits that can help treat mental disorders and mental affective disorders that are affecting many people. And for someone that has access to it, and for someone that understands how it works, and it's a lot easier. But for someone in my community who has been told, I've been told my whole life, never do drugs, never do this, never do that. All I thought about during that whole time is just Nancy Reagan saying, just say no to drugs. But in reality, it's like, in reality, you really think, what can we do to make all these tools, to make all this information accessible to people like me, so then they don't have to struggle as much. And if we really look at some of the current research, there are many limitations that are very significant that influence both the neuroscience and psychedelic research. These limitations are involved with just the subjective reliance on like surveys and like self-reporting. A lot of studies, they do clinical trials, they have certain amount of people, certain groups, that after they're done with the experiment, with the protocol, a lot of what they do, because there isn't really better ways to measure the experience of psychedelics, is through surveys. How do you feel? How are you feeling now? How do you feel before having a psychedelic experience, and how are you feeling now? So making those comparisons are really helping researchers do this type of clinical trials. We also have this observer-based assessment, which is the assessment that the ones that are actually doing the clinical trials, so the researchers and also the therapists, are there on and based in location, and they're looking at the behaviors, they're looking at the changes from for every individual before having the psychedelic experience and then after having the psychedelic experience. But also we have methodological constraints such as people going into these clinical trials and knowing who is getting the psychedelic drug, or who's getting the placebo. And this is really biasing a lot of this research. But at the same time, if we look at what's in the happening in the actual clinical trials. We see people that have either already done psychedelics and they already know what's good with it. They already know the benefits from it. But what about the people that have comorbidities? What about the people that are really not interested in this, but maybe they can benefit from this? They're not part of the research, and that is a problem. Even if we look at clinical trials in some papers that have come out in the last 10 years, is one after another, and after another, where they use server reliance, and they rely on that to get a lot of the information and to measure the experiences. That information, at least from my perspective, is not only not as accessible and as understood for someone in my community, but it's also not relevant, because people like me are really not part of these clinical trials. So for someone like our doctor, Mr. Bean, they will probably approve that type of research, but normally we wouldn't. So then the question arises and is, what is the solution? Well, machine learning. And you might be thinking, machine learning? What is this? Like, how can we introduce machine learning like AI into neuroscience research and the psychedelic experiences by itself? So the main question is, how can AI be used to model human consciousness and replicate the psychedelic experience? So AI in psychedelic research has advanced a lot. So one of the factors is that in AI models, we are replicating this human consciousness slash psychedelic experiences. We're somehow creating systems that are mimicking the structure and the function of what our brains are doing. But not only that, we have we're also getting an insight on the understanding the psychedelic effects, and also the effects not only peripherally in our whole bodies but also in the brain and behavior. How are people responding to psychedelics? But in this case, how is a system that is mimicking a human body, a human brain, to a certain lower scale, behaving after a psychedelic experience? And while still this still sounds weird as how can this be applied, this is also helping us overcome the limitations that I mentioned earlier, that reliance in surveys, the expectancy bias that we can have by people that have already done psychedelics, or they know what the whole experience is about, and they just go into the clinical trials because they want to be part of it. But in reality, how valid is that information that we are getting from the current clinical trials? And then the last the last factor that I wanted to mention, and is to me at least the most important, is the therapeutic potential. As a researcher, I love just doing science just for the sake of science and curiosity. However, it has to have a motivation. Motivation, there are many, but the motivation should be creating treatment to help the people that are struggling, to help the people that are in need. People that look like me in my community need a lot, a lot of ways to have treatment that are accessible and that they can receive in order to treat, in this case, mental health, which is something that I'm focusing in. So, how can we implement this? Some researchers from the University of Cambridge in the UK have created this system that's called the Spatially Embedded Recurrent Neural Network. And it's pretty much a simplification of a human brain that is creating this system that is um, somehow mimicking the structure of the brain as well as the energy consumption of the brain and the functionality. For us to understand this is that, as I mentioned in the beginning, in the introduction of this presentation, the brain itself has many, many hats. It's doing many things at the same time. It has patterns, it has the patterns of brain activity, depending on the time of the day, depending if you're asleep, depending on many factors. The brain is somehow keeping this homeostatic activity to make sure that we function well, that we function properly, that our machine, our body functions properly. In order to do all this, it requires a lot of energy. Brain is it's very expensive. It requires a lot of energy. And then of course, in order to do all of this, you need a structure that has a function. So that's what the spatially embedded recurrent neural network it's doing. It's having all these three important categories, which is the structure, the energy, as well as the functionality being the main parts, the main components of creating a neural network. And then this neural network is connected by nodes. These nodes are analogous structures of cell neurons. So we know that in our brain we have trillions of connections. And these connections are done from one node, or meaning neuron in a regular brain, from one neuron to another. They're making all these synapses, making all this communication from one to another. Well, the nodes are this artificial structure that work within the CERN system in order to create that structure and also to create that functionality. And then this idea that somehow we can create a system, a computer system that works like a brain, this allows us to introduce a psychedelic state, an artificial psychedelic state into this model. So in that way, we can obtain information from it and make it more accessible for treatment. So the steps for implementation. This is how it would work. We have the pre-induction and the post-induction. In step one, we have the network architecture design, meaning we're creating the structure. We're making sure that if we're looking at one mechanism in the brain, for example, the mesolimbic pathway in the brain, we're looking from the ventral tegmental area to the nucleus accumbens. We want to make sure that those connections are working properly in their place in the right place. Also, the second step would be training. Once we have the whole structure, the whole design, it's to train this model with real brain data. We can obtain EEG data as well as fMRI data, and we can introduce this into our artificial spatially embedded network to make sure that it actually behaves like a normal brain. The third step will be to do the integration of the psychedelic effect. And how would that work? That would work by, if we're creating a code in a structure that is similar to this pathway, we can saturate within the code the serotonergic system. So in that way, we can also create the psychedelic effects that we would see in a regular human brain. Then the step four, it's the validation and calibration. Once you run all the experiment and you've done the protocol, we have to validate the data. We have to make sure that the data that we're receiving it's proper and is behaving just like a regular brain. And we do comparisons and we do it over and over and over again until we see no difference between a regular human brain or the effects of a regular human brain and into this lower scale model. Then step five would just be to explore within the neuroscience research and psychedelic research to create questions. I think that psychedelics is a great tool that we can utilize to answer a lot of questions, but it can also give us more questions. And that's the whole point about this, to create more research, to create more science that will be connected to helping people to help in communities, because this is all about, this is what it's all about. Then this step six will be just to refine um, the system with experimentation. And by just doing this, we can create a bigger model that is just not based on one system, one mechanism, but we can add more to the point that we have a system, a model that resembles the brain quite well. uh, a quote that I took out of the manuscript from Dr. Atterberg, which is the researcher that created the system. And he says that the model provides an important tool to continue the work on jointly studying structure and function in neuroscience models. So, what is the novel piece of this method? We're inducing an artificial state, and this resembles the psychedelic experience in the human brain. This is very important because we're first designing a computational model that's mirroring the brain architecture, and we can also induce the artificial psychedelic state. The second is by mimicking the psychedelic effects through a neurotransmitter modulation, as we said, just a saturation within the code of the serotonergic system. We're also validating the data that we get, all the results that we get with human brain activity, and we are relating this information with actual real psychedelic experiences. Then last, we're just exploring neural dynamics and then inducing a deeper understanding of consciousness, of what gives rise to mind. So the impact and in the influence, we're advancing the understanding of the neural networks, cognition, and the neural correlates of consciousness, as I've mentioned already. And this is the second part is the most important to me is we're empowering therapy. We're empowering people. This is very personal to me. I've seen my dad struggle. I've seen my wife struggle because of, for example, an affective disorder, major depressive disorder. And we really think of what can we do to make people's lives better? What can we do to make sure that people are not struggling? The people that are around me are struggling for X and Y reasons. What can I do with my research? What can I do with my knowledge so it can be applied and it can help more and more people? And with this, we're also revolutionizing consciousness by transforming our understanding of human consciousness and its relationship with the brain. So in the end, the artificial psychedelic states are in service of understanding, treating, and modulating the brain. And this is very important. This is something that we keep in mind. We're treating, we're understanding, and we're modulating the brain. One of our future directions, things that we can see in the future with this type of research, if we're not starting somewhere, we're never starting. So we can do a small step to get closer into better models and to better therapies to help people. Scientific development. We want to make sure that all this development is being backed up by good science. So all the outcomes are good for people. So we can also understand this a lot better. We can also replicate this system in bigger models, creating models that are each time resembling the brain structure and function more and more and more. By creating also a therapeutic impact, by finding new ways for people to get better, to feel better, to become better. And last, and very important, to transform people and transform communities, to change our society through tools of psychedelics and neuroscience research that we can use to help people, to help all of our communities, and to help all the people around us. The power of neuroscience research and psychedelics is necessary to advance our understanding of the human brain and unlock new therapeutic benefits for those in need. People that look like you, like me, like my cousin, like my aunt, like my neighbor, like the people at my church, like the people at my school, the people at my lab. No matter nationality, it doesn't matter culture, race, ethnicity, language, religion. We're utilizing these tools to help people that are struggling, to help everyone. Thank you so much, guys. My name, once again, is Victor Manuel Hernandez. This is some of my information. That's my email. And fun fact, I actually share birthday with Albert Hoffman. Thank you so much. You guys have a great